Hi children, today I am going to start with a new chapter P block elements for the 12th standard students. In this session I am mainly including the introduction of P block elements and the second case about group 15 elements I am going to start today. In this group 15 elements, in this video I include occurrence of group 15 elements, their electronic configuration, explanation, and also atomic radii and ionic radii, about the group 15 elements, the ionization enthalpy variation along the period and group, electronegativity difference along the group and period, and also the physical properties of group 15 elements. Together we can discuss in this video. This is our periodic table. What is P block elements? In the 11th standard you studied about that. Group 13 to group 18 elements together we are calling the name, it is P block. Why the name P block? Because when you start to write the electronic configuration of that elements, their electronic configuration ends with, here when you take carbon it is a P block, no? Carbon. Try to write the electronic configuration. Carbon atomic number is 6, 1s2, 2s2, 2p2. So the last electron entered in the p subshell. That's why this carbon belongs to the P block. So any other element here, neon, you have to take it, neon, 1s2, 2s2, 10 is the atomic number. So 1s2, 2s2, 2p6. So 10. Okay. The last electron entered in this p subshell. That's why this also belongs in P block elements. So when the last electron, when it enters in a p subshell, that element belongs to the P block element. Here in this P block, when you consider, in the case of helium, you can see the exception. Why helium? It is having the electronic configuration 1s2. It is not the last electron enters in the P block, then also it is included in this P block because it is having the same characteristics of this noble gas elements. Okay, then here the P block elements, last year you studied about this group 13 and group 14 elements. This year we need to be study about group 15, group 16, group 17 and group 18 elements. So today I am going to be explain on this group 15 elements. Okay, so why this P block element? It is having diversification compared to S block, D block and F block. You can see that when you start to electronic configuration, here this is the first period and this is the second period and this is the third period. So when you write the electronic configuration of the second period, last electron enters in the P, and in that electronic configuration you can see S and P subshells only. But when here aluminum silicon, third period onwards, fourth period, fifth period, sixth period, seventh period, likewise when you go through this P block elements, you can see that here an atomic number increases. So when the atomic number increases, there is a chance of including D and F subshells in this electronic configuration. So when you compare, you can understand that in the second period you can see only P block element, P subshell. That means absence of D subshell though, but in this third period onwards you can see that there is D and F subshells though. Then not only that, the P block elements, when you compare, you can see that here the green color portion, it is indicated by non-metals. This indicated by semi-metals or metalloids, this orange color portion. Then this part, it is indicated by metals. So here you can see that it is possible to see three types of elements, that is metals, metals, semi-metals or metalloids and non-metals. So these three types included only in P block compared to other D and S and F. So that also makes this diversification of the elements compared to the other block elements. So that's why we can say that p block elements study, it is an important case. 3 points we discussed, that is absence of d orbitals in the second period and presence of d and of orbitals in the heavier elements, that is from third period onwards. And the third one, there is a metals, non-metals and semi-metals or metalloids, it is present. That is the reason for the special diversification in the case of this p block elements. Okay. Then general electronic configuration of the p block elements is here, as I written, 1s2, 2s2, 2p3, 2p4, 2p5, likewise the situation. So we are generally written as ns2. Last shell's electronic configuration only we are considering. We are representing in the general electronic configuration. So here ns2, np, 1 to 6. This is the general electronic configuration for the p block elements from 13th to 18th group except helium. Now we can start the discussion on group 15 elements. What all elements present in this group 15? It's very familiar elements to you. Nitrogen, phosphorus, arsenic, antimony, bismuth. Among these, nitrogen and phosphorus are non-metals. Arsenic and antimony are semi-metals or metalloids. Bismuth is the metal. So you can see that metallic character increases when going down the group. Non-metal is the first, then it is going to semi-metal and it reaches to the metal. So metallic character it increases as we going down the group in the period. Next one about occurrence of these elements of group 15 in the p block. Okay, so here in the case of plants and animals, you know that nitrogen, phosphorus, arsenic, antimony, bismuth is about 78% of the earth crust it is filled with nitrogen. In the case of nitrogen, it is existing in the plants and it is able to be seen in the case of plants and animals in the form of proteins and nitrates. Nitrates, it is existing as in two forms. First one is sodium nitrate and the second one is in the case of potassium nitrate. Sodium nitrate, it is having one common name, that is chili saltpeter. Likewise, one question may come in the one word session. Chili saltpeter, what's the chemical formula? NaNO3. So the next one, potassium nitrate, that is Indian saltpeter. Niter also one common name it's there. So likewise in the plants and animals, this nitrogen it is existing either in the forms of proteins or in the form of nitrates. When it is occurring in the form of nitrate, it is existing as first one sodium nitrate and the second one potassium nitrate, and also ammonium salts in the soils of desert region. Okay, likewise it is existing the nitrogen in this earth crust. Then about phosphorus. Phosphorus is mainly occurring in the form of mineral of the apatite family. So apatite family means it is this formula. Apatite family means Ca3PO4 6 times CaX2. In this case of X, there is a chance to become fluorine, chlorine or OH. Yes, one of the example for the fluoroapatite family it is Ca3PO4 6 times CaF2. Yes, it is this phosphate form, it is present in the phosphate rocks. Then this phosphorus, another important thing of this phosphorus it is an essential component of animal and plant matter. Then this phosphorus it is present in bonds and also living cells. And this phosphorus it is one of the form of the phosphorus, it is phosphoproteins, it is present in milk, egg and fish. Okay, so the occurrence of this nitrogen and phosphorus we completed. Next one, arsenic, antimony, bismuth, it is found in the sulfide ores. Okay, now we can start with electronic configuration. So I told already nitrogen, phosphorus, arsenic As, antimony bismuth, antimony Sb, bismuth Bi. So their atomic number also I written here 7, 15, 33, 51, 83. Their electronic configuration I mentioned here. In the case of nitrogen, 1s2 2s2 2p3, then phosphorus again 3s2 3p3, 4s2 4p3, 5s2 5s3 and 6s2 6p3. Likewise, the electronic configuration it comes. So here in the last shell, when you consider, you can see that there is a 5 electrons, 5 valence electrons it's there, and every one it is ending with p3. You know that in the p subshell it can maximum accommodate 6 electrons, but here you can see that in every cases it is having p3. What's the meaning of that? It is half filled. This p3 maximum 6 it can accommodate, but it is filled 3, that means it is said to have half filled stability. So that's why this group 15 elements it is said to have extra stable, because of this half filled p orbitals and fully filled s orbital. That's why we are saying that when you start to write the electronic configuration, you can understand the same. What? The p block elements, group 15 elements are, it is extra stable. Why? Because of the fact that S is completely filled and P is half filled. That's why it is having extra stability. And next one, we are discussing now about atomic and ionic radii. Atomic and ionic radii, about that you studied from the 10th standard onwards. You know that I will show the periodic table again here. From left to this one, no, left to right in the periodic table, you can see that what happens, atomic radii it is decreases, or atomic size it is decreases. But when we are going down the group, what will happen? It will be increases. Why? Because you studied the reason. The reason, nitrogen and oxygen. Nitrogen is group 15 family and oxygen is the next family. I just drawn nitrogen 7 is the atomic number. So first shell K shell, this is the second shell L shell. The first shell you can see that 2 is the maximum accommodation, 7 is the atomic number, means 2, 5 is the electronic configuration. So 1, 2, 3, 4, 5. Okay, so this is the Bohr model of this nitrogen. And oxygen, when you start to write here, 8 is the atomic number, so 3, 3. Okay, you can see that which one is having more effective nuclear charge. You know that here 2 electrons and 5 electrons here, but here 2 electrons, 6 electrons in the next shell. So this positively charged center, here there is a nucleus, here no. The positively charged center, there is a 6 positive charge here, there is a 5 positive charge here. Then this positively charged center, it has more attraction from more electrons. So which one is having more attraction? Because here in this case of this outermost shell, it accommodates 6 electrons. Here 5 electrons only. So this oxygen, it is attracted towards this nucleus more compared to this nitrogen. So when this last shell, when it is attracted towards the nucleus, what happens? This shell, it is completely going towards this nucleus. So it is reaches near to the nucleus. So what happens to this structure? This is the first shell and this second shell, it is going to be near to this first shell again. So what happens to the size? It is reduces. What's the reason? Because of the attraction of the last shell towards this nucleus. One single word we are using for that, the attraction, effective nuclear charge. Effective nuclear charge, when it is increases, automatically we are saying that it is atomic size, it is decreases. That means that attraction between the last shell and the nucleus. When we are going down the group, nitrogen and next one phosphorus, I written one more shell. Here only 1, 2 shells. The electronic configuration, from that you understood that the P it is having 3s2 3p3 is the outer electronic configuration. So here I drawn first shell, second shell and third shell, it is having 5 electrons. As you return the electronic configuration, from that you can understand. But here only 2 shells. That means from when the shell number increases, automatically size increases. When the size increases, what happens? Effective nuclear charge, it is decreases. So automatically atomic size increases, atomic radii increases. So what about ionization enthalpy? Compared to these two, this is the period case I have shown and this is the group case. So what about the ionization enthalpy? Ionization enthalpy means you know that the tendency to lose most loosely bound electron from an atom, from an element. Tendency to lose most loosely bound electron. So from this one electron we need to remove, from this one electron we need to remove. Which one it is more favorable to remove? It is in connection with atomic size. You studied that along the period compared to nitrogen and oxygen. When you compare nitrogen and oxygen, you can see that oxygen is having less size. So when this oxygen it is having less size means it is more attracted towards this nucleus. So there is a nuclear attraction, it is more. So is it easy to remove the electron from this oxygen? No, it's not so easy because these electrons, these 5 electrons, it is very close to this nucleus. So much attraction from this. So from that one electron removal, it is very difficult. So for that we have to be apply large amount of energy. That's why the nitrogen's case we have to be apply less amount of energy compared to oxygen. And that's why the ionization energy, it is less for nitrogen and more for oxygen. Okay, then down the group what happens? Down the group you can see that the shells increases, so atomic size increases. So when the atomic size increases, what happens? Easy removal. Why? When size increases, it is this last shell, it is far away from the nucleus. So not so much attraction, so it is easy to remove the electron from this last shell. So less amount of energy it is needed, so ionization energy decreases. So we can conclude that when we are going along the period, you can see that atomic size decreases. Because of atomic size decrease, ionization enthalpy it is increases. But here when you go down the group, because of size increases, reverse case, ionization enthalpy decreases. Okay, so comparative study it is needed. Down the group that we are discussing about group 15 now, but in the case of period when we are discussing, when you compare the group 15, you can see that along the period, the group 15, it is having more atomic size compared to group 16. That means in the oxygen. Okay. Then less atomic size compared to the group 14. Then compared to group 14 and group 15, group 15 is having high ionization energy because of group 15. It is having the size at about atomic size, you can say atomic size it is decreases. Not only that, there is one more facility we already discussed. It is having S2P3 configuration. So half field stability, extra stability also there. From the extra stable one, it is not easy to remove electron. That also one reason. Smaller size we already discussed the reason, and one more reason it's there, that is extra stable situation. That makes more difficulty to remove the electron from group 15. So ionization energy it is high for group 15 elements. Then we studied in the earlier classes about first ionization energy, second ionization energy and third ionization energy. So first ionization energy means one electron removal. When we remove one electron, for that how much energy you used? That it is first ionization energy. Okay, then second, so after remove one electron, that element it got positive charge. Then from that positively charged element we need to remove one more electron, right? So from the positively charged one, that means it is already having the loss of electron. From that we are removing again one more electron. It's not easy. That's why the ionization energy is more again. Why? Ionization energy, we need to be apply more amount of energy for that second electron removal from the positively charged species. Then after this removal you will get 2 positive. Then from that again one electron removal. It's very difficult. So again ionization energy it is increases because of the difficulty to remove the electron from the second positive charged element. So that's why we can say that the third ionization enthalpy it is greater than second than the first ionization enthalpy. Here I mentioned the values of the ionization enthalpy of the group 15 elements. The first ionization energy only I mentioned. So here when you look at, you can see that down the group what happens, we said about that ionization enthalpy it is decreases because of the size increases, easy removal. So you can see here the values 1402, it is the first value. Then when we are seeing, you can see that it is decreases down the group. Okay. Next one, electronegativity. Electronegativity means what? Tendency to attract the electrons towards itself. Tendency to attract the electrons towards itself. But you know that when we are going down the group size, it will be increases. So which one having the more easy to attract the electrons towards itself? Less sized one. Surely you know that. So the first elements and all, it is having more electron negativity. But when we are going down the group, electron negativity decreases because of the size increases. There is less attraction towards this nucleus. That's why. Okay. That is only about electronegativity. Now we can go to the physical properties. Physical properties of nitrogen, phosphorus, arsenic, antimony, bismuth. We need to be discussed today. So here we are considering as these all elements in the group 15, it is existing as polyatomic. That means more than one atom. It is existing in this nature. Nitrogen, you know that it is existing as a dimer, N2. Diatomic gas. It is existing as in the form of a gas. Next, P4 phosphorus, it is existing as a tetramer. Arsenic, antimony and all, it is existing as a tetramer. This all existing as a solid one. Okay. The next one, metallic character. We already discussed that what it is metallic character. Then nitrogen and phosphorus, it is non-metal. Then arsenic and antimony, it is semi-metals, and bismuth, it is a metal. So what about the metallic character? Metallic character increases when we are going down the group. Metallic character means what? Tendency to lose the electrons. Why it is easy? Because when you are going down the group, what happens? The atomic size, it is very high. So what happens? It is easy to remove the electron. Tendency to lose the electron, it is more easy for this bigger elements. That's why it is said to be that when we are going down the group, it is easy to remove the electron, and we can say that it is metallic character increases down the group. Okay, reason it is increased atomic size and also decreased ionization energy. No difficulty to remove the electron because less amount of energy is needed. Okay, that is we mentioned here metallic character, it is increases as we go down the group. Okay. Next physical property, it is boiling point and melting point. Here I mentioned the values of this boiling point and melting point of the group 15 family. That it is boiling point values, it is 77.2, 554, 882. Likewise, it is increases going down the group. You cannot see any variation in between. Why it is regular increase? You can see because of the fact that there is the strength of van der Waals force of attraction between the nonpolar molecule, it is increases. When there is a strong interaction, more amount of energy it is needed to be applied. That's why the boiling point, it is increases. But in the case of melting point, you can see that first it is increases. Here is 61, 317. But here you can see that there is some decrease. From nitrogen to arsenic, it is increases, but afterwards it is decreases. Yes, what's the reason? Here also one more thing you have to be noted down. When you compare the boiling point values, you can see that there is a gradual increase in the boiling point here. 77, 554, the sudden increase. But here when you look, not such a big increase you can see, because this AS, the arsenic, it has a chance to be sublimes. That's why it is not so much big increase you can see. But then also it is gradual increase. Okay, then but in the case of melting point, when you check, you can see that till arsenic there is an increase, but afterwards it is going to be decreased. What's the reason? Because of the fact that, as you know, the 5 is the valence electron of this group 15 elements. So there is a chance to be formed 5 covalent bonds for each element. So all these members, they are preferring 2. But in the case of these 3, they only form 5 covalent bonds. The rest 2 forms only 3 covalent bonds due to their inert pair effect. That is the reason for reducing the melting point for this antimony and bismuth. Okay. Next one, allotropy. Allotropy means the one element can existing in different forms. So here in the case of carbon, you know that carbon is the another family. Then also you know that fullerene, graphite, diamond. Likewise, different forms it is existing. Likewise, here in the case of group 15, except nitrogen, rest all members they forms allotropic. Okay.